Let's consider the question on the board. We are asked to take the limit of 2x squared plus x minus 1 whole over 3x squared minus x plus 1 as x tends to infinity. Now, because infinity is not an actual value, you understand? It doesn't have an actual value, so we need to manipulate this function, you understand? Are you getting what I'm trying to say? We need to manipulate the function by dividing both the numerator and the denominator by the highest power of the variable of the denominator. Listen to the explanation again. It's simple. Now, you can see in that question, x tends to infinity. Infinity is not an actual value, you understand? So we have to manipulate the function. How do we do that? By dividing both the numerator and the denominator by the highest power of the variable at the denominator. You can see now the highest power of x at the denominator is what? Is x squared, you understand? So the first step is that I'm going to divide both the numerator and the denominator of this function by x squared, you understand? Now if I have x cubed, I'm going to divide both the numerator and the denominator by x cubed, you understand? So now because I'm having the highest power of x at the denominator is what? X squared. So I'm going to divide both the numerator and the denominator by x squared. So the function becomes like this: 2x squared all over x squared, you understand? 2x squared all over x squared plus x all over x squared minus 1 all over x squared. Now put the division sign. This 3x squared all over x squared minus x all over x squared, all over x squared plus 1 all over x squared. Okay, now for this we're going to have 2, you understand, plus 1 over x plus minus 1 over x squared, 1 over x squared. Okay, this all over 3 minus 1 all over x squared plus 1 all over x squared. Now the final answer to this question will be 2 all over 3. I'm going to explain, just pay attention. In our previous class we learned that if you take the limit of a function of this kind, 1, 2, 3, 4, if you take the limit of a function of this kind as x tends to infinity, you are going to have 0. You understand what I'm saying? So if you miss the class, kindly check the link in the description of this video to watch the class. Okay, so the final answer to this kind of question is 2 over 3, and the reason is because all this will be 0, this will be 0, this will be 0, and this will be 0. Okay, so now for the next question we have limit 4x squared minus x all over 2x cubed minus 5 as x tends to infinity. We are still going to go the same way. First step is divide both the numerator and the denominator of this function by the highest power of the variable. The variable here is x, you understand? So I'm going to divide both the numerator and the denominator by the highest power of x at the denominator. The highest power of x at the denominator is what? S cubed, you understand? So for this I'm going to have, please pay attention, I'm going to have 4x squared all over s cubed minus x all over s cubed, this 2x cubed all over s cubed minus 5 all over s cubed, you understand? So for this we're going to have 4 over x minus x all over x squared, this all over 2 minus 5 all over x cubed. The final answer will be 0. Do you know the reason? Because the numerator here will be 0, 4 over x will be 0, x over x cubed also will be 0, you understand? 2, okay, this is what we're going to have: 0 minus 0 all over 2 minus 0. This is what? 0 over 2. You can see now. I hope you understood what I did. Listen to me, listen to the explanation again. If you are taking the limit of a function to infinity, you understand, infinity is not an actual value, so we have to manipulate the function. And another method of dealing with question on limit is that you divide the function by the highest power of x at the denominator, you understand? So, and that's what I did for the first and the second question. So having done that, I discovered that if I saw infinity is not an actual value, and in our previous class that we have learned that the limit of a function like this as x tends to infinity will give us 0. So this will give me 0, this will give me 0, this will give me 2 because it doesn't have x, and this will give me 0 as well. So I have 0 over 2. What is 0 over 2? It's not an actual value. So the limit of that function as x tends to infinity will be 0. You get what I'm trying to say? Now, if you look at this kind of function, please pay attention. If you look at this kind of function, it's not that their limit does not exist. You understand? Most time, it's not that their limit does not exist. It's just because maybe the method that we use is not suited. It's not suitable for the function. You get what I'm trying to say? And that's why I explain many. We talk about many methods. You understand? I think we've talked about direct substitution method, simplification. Now we are talking about manipulation. This one is just like a method of manipulation. You understand? You manipulate the function by dividing both the numerator and the denominator by the highest power of x. Now, if that method does not work, there is another method known as L'Hospital rule. You understand? We're going to talk about L'Hospital rule. That's the next method that we're going to talk about. L'Hospital rule.